talk about some interesting graphics technology from ATI and show how they help you as a SolidWorks professional. Make your job more interesting, a little bit more fun, and also a little bit more productive. That's our agenda for today. We'll do a quick introduction. I'll tell you about me, and I'd like to know a little bit more about you guys and what you're doing with SolidWorks. We'll look at a few new aspects in SolidWorks, some of the things that have come out from a graphics perspective in the last couple of years, and try to understand their impact on graphics and also the way you do your job. We're going to talk a little bit about consumer versus professional graphics. Probably one of the biggest questions we get most frequent is, what's the difference between consumer and professional graphics? They're cheaper and less to buy consumer. We'll talk a little bit about that. We're actually going to do a head-to-head demo today to show you some of the advantages of professional graphics versus consumer. We've got an interesting demo. We'll talk a little bit about remote display technologies. The cloud's the big buzzword these days. You've probably all heard it. So we'll talk a little bit about remote display technologies and what's going on there and do some demonstrations. We'll talk a little bit more about multi-display technologies. A lot of people have more than one display on their desktop, and we'll have some interesting demos here. We're lucky to have a SolidWorks user, an educator with us today, who's going to actually walk us through some demos and show us how multi-display technology actually aids in design. And then we'll have some questions and answers. And finally, we got big prizes. So kind of a small group today, so your odds are pretty good. If you didn't get a ticket, we'll get you one at the end. So if more people come in, your odds are going to go down. So I don't know if you want to barricade the door or not. So introduction. My name is Alan Bourgoyne. I'm on the head slot. I've been in graphics now for about 25 years. Majored in college in the early 80s. Computer graphics was just getting started there, so I took some graphics courses because of, believe it or not, the movie Tron. I saw that thing and I said, graphics looks kind of interesting. So the class came offered, random class, I took it, and I went and saw the new Tron. I'm going, it didn't inspire me the way the first one did. I guess 25 years does that. But I've been working with it quite a while. I head up the ISV Alliances team for AMD for professional graphics, so we work with a number of software developers like SolidWorks to make sure that we provide the right technical support and business support, make sure that our products are certified and tested, and that the experience you get when you buy those products is going to be top-notch and supported. So I'd like to know a little bit more about you guys. How many of you use SolidWorks on a daily basis? Are designers and use it every day? How many of you guys know what graphics cards in your system today or have some influence on what the hardware is that you buy? A number of people. How many of you guys saw me speak last year at SolidWorks World? Nobody, that's good. It was the best presentation at SolidWorks World. And if none of you guys come back next year, this presentation is going to be the best one. So I've been a couple days at SolidWorks World, and I know I've learned some lessons. Hopefully you guys are learning things. There's an old adage, there's two kinds of luggage, there's carry on and lost. What we've learned here in the last couple of days is a car loader. And that is, there's two kinds of demo equipment. It's the stuff you brought with you and lost. Stuff that trade show shipped. So none of our demo equipment that we actually had scheduled for this room today showed up, so we kind of cobbled some stuff together in the last couple of days. So some of the demos will have some data on the slides that might vary a little bit from what we've done here today. But hopefully things will work. We've actually gone through this a couple of times. Things look like they're really okay. But bear with us on the demos. And anytime you ask questions, there are no bad questions. I like to think of degrees of greatness. So if you have a great question, great. If you have a greater question, that's even better. And of course, questions are always rewarded in our sessions. So if you come up with something good, we got some swag that we stole from the marketing guys. They don't know we took it yet. So what's new in SolidWorks 2011? RealView has actually been around for quite a while in SolidWorks. And if you use AMD Professional FirePro products, it's enabled. If you buy a consumer card, you actually can't enable RealView. But you'll see kind of the differences here on the far side here. Just kind of a flat shaded model. Here we've got reflections, shadows. We can do a lot of different things. And really the goal is to give you a more lifelike experience when you're rendering. How many of you guys get your marketing people coming in and said, hey, I'd like to show this design to a customer or a client, right? You guys get that all the time, right? And make it look pretty, right? The problem we have is our experience at home. We watch movies, we play games. Their level of realism is really high. And so our marketing guys and our business partners want to see that degree of realism in the product. So RealView is SolidWorks was probably ahead of the curve of putting that in their product a few years ago. We worked closely with them, making sure that would work well in the product. So it's a very useful feature, but it does put more demand on graphics. Full screen and the LSM support. So this one, I'll flip through a few slides just to show you. NELC is really, what you want to do is you want to remove the jaggeds, right? Those little jagged lines. If you draw something, you look at your screen, you see those jagged lines here. But what NELC does, it actually helps smooth out those lines to some extent. The projector doesn't do it quite justice. But the technique that it uses is the graphics card will actually sample the color right around that little jagged point. So it'll read additional pixel positions right next to it, and it'll kind of average it with color. And so what you get is a much smoother line. So the benefit is much more realistic and high quality images and much more pleasing images to your eye. The challenge is it takes more memory and graphics horsepower because instead of just drawing this line, now I've got to look at everything that's next to it, look at the color and do an average and draw that. So it definitely puts more demand on your graphics cards to do any LSD, but the end result is really nice. And we get these nice pictures that we like and our customers and partners like. PhotoView 360, so they've actually integrated that into the product now, so that's where you can actually do realistic rendering, you get nice lighting and reflective surfaces. Again, people come to you and want something for a brochure or something for a slide for a campaign. A lot of people use PhotoView to dump that out. And with walkthroughs now, people want to go through very large structures. They want to walk through kind of video game style, so I want to look at a plant. I want to be able to walk through these assemblies or go in there and look and see what the interconnected assemblies look like. So again, when you start looking at things like PhotoView and plant walkthrough, people want an immersive environment. They want things to look like the real world. I want to be able to walk through it, and it better look like what I'm used to seeing. So again, that bar is set really high in the eyes of the consumer, and so again, it puts a lot more stress on the graphics cards. So when you look at this, but turn not only in the SolidWorks system more realism. People want things to look more realistic everywhere, right? Not just in graphics, but in our cell phones and our movies and video games, you name it. But it puts a much larger workload on our complete system, both our CPUs, our graphics, memory, I/O subsystems. It's really taxing the system. So it's more important than ever to understand what your needs are when you're making these hardware purchasing decisions. You don't want to buy something today that's going to be obsolete when the next version of your software comes out. So it's really important to figure out what your workloads are and make the right decision. So consumer versus professional graphics. There's a couple of pretty widely held assumptions. The things that people come and ask me the most are, consumer graphics are exactly the same as the professional graphics, and they're ready to buy a professional graphics card. Widely held belief number 2 is that consumer graphics cards are cheaper than professional cards. Go and get them a lot cheaper than I get any professional cards. I'm going to save money because it's the exact same card. Both of these are wrong. AMD professional graphics cards provide you a lot of benefits that are not available on the consumer side. If you look at built-in warranty by AMD, we actually build pro graphics cards and we actually warrant them through AMD. Consumer cards are built through third parties, and so you're subject to whatever warranties and service they want to provide. So again, quality varies. I know we bought a couple of cards and some of them are good and some of them are not so good. So you're kind of really at the mercy of that manufacturer and they're not really backed by AMD. Professional cards are tested and certified by SolidWorks. We actually work with SolidWorks. We have engineers who work with them. We have their test suites in-house. So before our graphic drivers go out, they've been tested with SolidWorks, and so you've got a pretty good confidence level that when you buy one of our cards and use our drivers, it's going to work well. Consumer cards, they're really focused on games. They test Far Cry, they test those kinds of things. They only look at SolidWorks. So there's no guarantee that that driver is going to work at all with SolidWorks, and in many cases they don't. Hardware and software tested against numerous professional applications, including SolidWorks. So most of us use more than one application. How many people use just one application and nothing else on their computer? Right, we use a number of things. So part of the efforts we have in our group is we want to make sure we test that hardware with many combinations of software, professional applications, to make sure that the combinations, interactions are going to work. And you definitely don't forget that on the consumer side. SolidWorks features are fully supported. You get all the features of SolidWorks on consumer, things like Real View. Some of the other features don't work. They just don't test them, and so they're not recognized as a tested and certified card. So SolidWorks actually disables those features in the software, so you can't use them. And then solutions start at $99. We both have that. You can actually get graphics cards for a very reasonable price. We've worked really hard in the past few years to bring the price down on professional solutions, so you can get pretty much cards to meet any budget. So I don't believe the money use is valid anymore. You can actually get a pretty comparable card for the same dollars, whether professional or consumer. So next we want to take a look at a live demonstration. So kind of click on the slides here. We want to do a head-to-head consumer versus professional graphics. So this is the original test setup we had shipped. That's somewhere, we're not sure where. We've kind of got an analogous system here. Our goal was to shoot for a $99 card. So we went and bought a Radeon card. On the street at Fry's for 98 bucks. We put it up against one of our V3800 cards for $99. So pretty much the same price card. And the test for us to use SolidWorks 2011, we have a little script that's going to rotate the model arbitrarily 250 times. And then we're going to record how many frames per second that graphics card can refresh that display to hold that model. The original test systems were Dell T1500s. We were able to scrounge a couple of Dell T3500s, so identical systems. And since we didn't have our cards, we actually went to Best Buy. There's no Fry's in San Antonio. Best Buy, we got a $140 card, so we stuck a $140 Pro card in here as well. So it's a 4800 versus a Radeon 55,000 series, which one is. But so the goal was to put together similar systems to what we have in our original demo. And so we'll take a look at the test live. So Olivier is going to start out both of them at the same time. We got a consumer on this side. Pro, notice the fancy signs that we have that didn't show up as well. So it's like kind of wiggling up a Sharpie and some paper before it's good. So we'll let them go. We'll keep an eye on what's going on the race here. So Olivier, can you fire? Okay. So it's going to run through about 4 models. You probably recognize these models if you've been to some of the booths downstairs. This is off the demo disc that SolidWorks gave everybody to have models that we have rights to show. You can see the Pro guys already finished the first one. It's pretty good. He's off to the second model. He's spinning, so he's starting to pull away a little bit from the guys. These models are probably medium-sized model, about 400,000 or 500,000 polygons each. The last model is going to be about, I guess, about 200,000 polygons. So yeah, he's pretty far now. He's on the third test. Along with where C scooter. And the final one, the Pro's actually on the final test now. He's actually rotating a little carving knife, but makes you hungry some turkey for Thanksgiving. So he's done. We actually got a couple tests ahead. So. Of course, the consumer guys finished now. So again, kind of a small example. You know, and we don't like to think there's any loser at SolidWorks World, so the consumer guy, nice try. But again, if we look at the data, and here's the data we got at the lab when we did the original test system that we're showing out here. If we ran each of the benchmarks 3 times, and we averaged the scores, we want to kind of throw out any kind of cache warm-up or any other latency issues on the machine that might come. So we ran it 3 times. And if you notice, the FirePro card was always faster, in some cases almost twice as fast than the first model. And overall, it's about 30% faster. On average. So again, this is $99 cards. If you actually take the card and go up the scale, you'll see that delta actually go out a little further. So again, I don't know about you guys, but 30% back on productivity is not bad. Return on your investment there, again, for the same price. So, you know, the professional card really significantly outperformed it. I've heard people on blogs, and I've heard people tell me live they wish SolidWorks would go to DirectX because then we wouldn't have to use Pro cards, we could go use consumer cards. That's actually not the case. We actually tune our drivers for DirectX as well. SolidWorks, unfortunately, doesn't have any of those products for sale, but we could run the same demonstration on a number of DirectX products and see the same result. So it's not only OpenGL, it's professional applications. We don't really care what the graphics technology, underlying technology is. We want to make sure graphics performance on professional applications run better on professional cards. And so we strongly recommend that you use the professional cards for any of your professional applications. So remote display technology, if anybody has any questions on that, we'll move forward. I won't leave a lot of time for Eric at the end. So I'll move this pretty quickly if you have questions. So remote displays, this is one we see a lot of interest and demand in. Do any of you use any kind of remote technologies today, any remote display technologies in your environments? Cloud computing is kind of a big buzzword. And when a lot of people talk about this, they talk a lot of different things. They'll talk about software as a service. I log into some cloud, some machine somewhere. I can access the software that I want to use. I'm going to pay a licensing fee or a time of use fee. But it's basically a service that I log into and subscribe to. Some people want to have multiple users per hardware instance. So I want to have a server, I want to have multiple people log into that server, get the software they need, and be able to have my IT efforts consolidated into a single box. So a lot of different ideas what's going on there. We've got mobile and portable devices. So how many people have smartphones or tablets? So that paradigm continues to grow. As we get more of these, it's more interesting. How do I use these remote devices over these networks, this cloud area, to be able to serve applications and data? We We need data security, right? We got to keep it secure. You don't want people snooping on your data, especially your proprietary designs that you're developing. That's your IP and your money. So you got to keep it secure. And then there's a lot of people who really want to maximize compute space and density. If my server room, compute room is only this big, and I can't add any more hardware without building a new building, I got to figure out how do I maximize the space and uptimes the power and cooling that I have available to maximize the compute service requirements for my users, which grows almost on a daily basis. And if I have minimal desktop space, how do I have monitors only and get rid of those big boxes? Like we have a pretty big Dell system over here. That's a pretty big system to put in an office, right? How do you get rid of that and get it out of there so you have more space in the office? So, you know, a typical remote graphics system, they look something like this. You've got systems, you've got thin clients, you've got networks. So what's kind of the trend of things? We're decentralizing and moving things out, moving things around, and we have both combination of wireless and wired technology in these clouds. So in a response to this, we actually developed some new technology. Our first product was our FirePro RG220 remote graphics workstation card. And so this is a picture of what the card looks like. Pretty traditional graphics card, except we've added a few new features. One, there's a PC over IP compression chip. So this chip on the board actually compresses the video signal going out the card, so we can then send it over an IP network. And there's 2 network jacks, standard RJ45 jacks on there. So you can actually plug this card into your network and have the displays remoted out over to a thin client. It also has a standard video output. This is actually DMS59. It almost looks like a display port, but you can actually plug it in there and have a couple of display ports in there as well. But it's a standard PCI chip, and of course graphics processor on there. If you look at the edge of the card, here's the normal kind of graphics output, and here are those 2 network jacks where number 2 is actually an output, so if you want to send that out to the network with a thin client, and number 1, you can actually chain these things together, so I have the input from another one of these parts coming in. So we actually have a configuration here today. We call it our SolidWorks Cloud Fabric that we're able to reconstruct for some parts we have laying around. So we've got as a server, we've got a Dell T7500 here. That's going to be our server today. We've got one of these RG220 cards in there. We've got a network hub. We went to Best Buy and got ourselves a Netgear wireless hub, or 4-port hub, so that's going to be our network infrastructure for today. And we've got a thin client. We're able to scavenge a Dell FX. I don't know if you can see this, we can hold it up on a 100 thin client. So on this thin client, it's got mouse and keyboard, and we've got it sitting on here on the desktop up here. It has video out onto the monitors there, and it has a network cable that's running on the floor over to our hub. So this is our thin client today. And so let's take it for a drive. So here's one that's going to drive for us today. And just switch the monitor over so you can actually see. So we've actually logged into our server. You can actually have multiple instances of that card and actually multiple clients running in there. So we've got a virtual session connected to our server. We're actually driving over the thin client. And so as you can see, we get pretty good response. We're actually using SolidWorks. The graphics in here is equal to about an entry-level card, not a high-end card in the RG220. But you see we get good performance. And you can have multiple cards in there, and if you use something like any of the virtualization software like Parallels or something, you could actually assign different cards to different users and different applications and different environments. So we're running Win 7 here. We could be running any flavor of Windows or Linux or any other OS in there, virtualized off to the different users for different cards. Is this good? Yeah. That's not fun. Slides. So we're going to definitely see more and continue varied devices for compute. We'll continue to expand our offerings in these remote graphics cards. But it's tough to say where things are going to go. We didn't have iPads a year ago, and now they're everywhere. So the compute paradigms can shift pretty quickly, depending on market forces and how things go. So it's a pretty exciting time. We don't really know things are where they're going to go and where they're going to end up, but the key is to be flexible, and we look at these new technologies and be able to respond to customer demands. So visualization everywhere. That's where things are headed. That's what people want. So that's definitely the direction of the technology. So multi-display technologies. This is another area in display technologies where the hardware has moved pretty rapidly. Today, LCD panels dominate. How many of you guys have any of those old big tubes hanging around? They're kind of hard to get rid of, right? Because they weigh so much. But we just don't have them on our desktop anymore. disappear pretty quick. A lot of projectors. How many of you have conference room with projectors if you have them in here, right? A lot of projectors everywhere as well. Stereo. Anybody got stereo setups in your office right now? Right? So the paradigm's moving pretty quickly. If you look at display resolution, that's gone up pretty much as well. 5 years ago, 1024 by 1280 was the standard. Now you get an iPad, about a 9.5-inch screen that's got roughly that same resolution. So we're all at least 16 by 12. How many people are using something smaller than a 24-inch monitor these days? Yeah. Sorry, Sarah. I'll try to get you better. Try to get you. You at 17 or 15? 17. All right. Everybody's at 15. If they are, let me know. I'll save you something. But it's definitely going up. And an interesting part is aspect ratio. Right? We used to all be 4 by 3. Right? We used to be almost square. Computer monitor was almost all square. What happened? People started wanting to watch DVDs. TV is not square. It's 16 by 9. So the consumer space has almost completely moved there. It's really hard to find a glass manufacturer anymore who's making the old square screens anymore. I went to Dell.com the other day and I said, okay, 24-inch monitors, more than half for wide aspect. So, in a year or two, you may not be able to get a 4x3. It's maybe really hard. And if you try to buy a laptop, you just can't buy it. They're all wide aspect. So, and again, was that driven by things in the professional space? Not really. It was driven by TV, HD TV standards. So again, people get to a certain level of comfort and perception in their daily lives, and they bring that back in the workplace. And now I want a wide aspect monitor, because that's what I'm looking at. Like, that's what I'm looking at in movies. So interesting happened there. The number of desktop displays also increased. How many people are using 2 monitors on your desktop today? Anybody using more than 2? More than 3? So if you're using more than 2, I'll tell you, you probably have 2 cards in your system, right? What do you have today? ATI. There we go.
Here's display boards.
Yeah, good. Let me give that guy a t-shirt. Yeah, I got something else for you. I'm going to give you a t-shirt, but also a box of Kellogg's Fruit Loops, mini Fruit Loops.
Nice, man.
There you go. See, it always pays to use AMD products. Huh? You never know what you're going to get. Of course, we got to get Sarah a big one. But the number is definitely increasing on the desktop displays. And so, that's back here with my clicker. If you can go back, John Petty Research did a study on displays. Actually, for quite a number of studies that have been done in the last 5 or 10 years, and they gave people multiple displays on their desktop and they actually gave them tasks to do. And they measured their productivity, how quickly could they get things done, and how quickly could they get things done accurately. And what they found is about a 42% increase in productivity with multiple displays. Now, you will get to a point where you get to pixel overlap. If I give you 10, you get carpal tunnel in your neck, and you can't go that far, right? But having multiple displays significantly improves productivity there. And
did they say what was the optimum number in that study?
they only tested 2, and they tested wider monitors, pixel. And the only issue they found is people were doing text-based editing. So if I'm editing text, if I'm going through and editing, having multiple pages on the screen was good. But you did get to the point where there was an optimal number of pixels. After you get about 3,000 pixels wide on text editing, it was just too much. People were going back and forth too far. But in our line of graphics work, it really depends on what you're looking at, what the productivity levels. For highly graphic-intensive tasks, people kind of wanted the monitors to go until they had a spatial distance. After a couple of feet of spatial distance, you tend to, again, run back and forth too far. And so that's why you notice a lot of the larger screens are either curved, or we put them in kind of round configurations, because you do kind of get neck strain going back and forth with that tennis kind of action. And a big reason that this is happening is we all live in multi-application environments. Again, most people are using more than one application today, so it makes sense. It's really hard to toggle, alt switch between applications. So it's nice to have the screen real estate to be able to have all your applications. In the design land, we like to do iterative design analysis, right? We like to go through, work on our design, do our analysis work, then come back into the design. It's nice to have those applications or enough screen real estate to be able to come over and iterate through our designs multiple times. And we got multi-core CPUs. How many people have 2 or more cores on their desktop today? You got a lot more horsepower than you had. You can actually run multiple applications in a lot more efficient manner. And then with GPU compute, now we're starting to see offload of the CPUs with some compute on the graphics card. That's giving even more compute power today. So we can do a lot more than we used to be able to do in our systems. And with these immersive displays, we can do things like iterative design. We can do things like helping with publications at the same time I'm working on my design. I can dump stuff out to the tech pods, right? So it allows us to do multiple things, and it's a workflow, right? Instead of just working in silos, we're now just have our workflow on our desktop and move smoothly between all the aspects of our workflow. So this is kind of the genesis of our ATI multi-display Eyefinity technology. And so today what it enables us is to have 2, 3, 4, or 6 displays out of a single card. So if you look at our entry, we have 2 or 3 displays, depending on which card you get. 3 in our mid-range, high-end supports either 3 or 4, and then 6 on our ultra-high-end. So you can actually have up to 6 simultaneously active displays at one time out of a single card.
No matter what size?
No matter what size. So it's single, easy to use. Just turn them on and go. Before Eyefinity, you guys might be familiar. I had a card, had a bunch of outputs on it. So I could hook up one, I could hook up another, and then Joe went on vacation for the week and he had a big 30-inch monitor, so I decided I'm going to borrow that while he's gone. And you plug it in and it didn't work. And it's just there wasn't any support on the card itself to support all those outputs. It's a limitation of the hardware, nothing to do with software, just didn't do it. But now with Eyefinity, you can plug in 2 monitors, and then the third one, that one works. Right? Just plug it in. And in fact, this one has 4, that one works too. So, in effect, what Eyefinity is, look at the back of your card, however many outputs you have, you can plug them into a monitor. So, if you've got 2 monitors today, you got to go by the IT or your boss for a third one, give you some room to grow. But whenever you get it, you can plug it in and it works. And they can be varying resolutions. And it's a flexible configuration. I can just use it to run multiple applications. I can run one on each screen. Just extend my desktop, just like normal Windows, and put down an application in every display. I can group the displays. I can have subgroupings. I can say that, I'd like to run an application on these 4, run SolidWorks, stretch all the way across, so I can have some of my partners come in and take a look at my design. We might use the other 2 monitors individually to run some other applications, maybe a render or some other application that we want to do. Or maybe I'm designing something really big. We have what we call single large surface technology that allows you just to treat this as one giant virtual monitor. So if I've got 3 monitors stretched out, I can have 6,000 pixels of width, and I can just set it up as one monitor and let SolidWorks just go across. So people design big things, long things, sometimes just want to see more detail. So you want to zoom in closer and